All right, so this is the key to the worksheet on the algebra of functions. So number one, you're given function f of x here, which is a quadratic function, 2x squared minus 3x plus 1. And g of x is this linear function, 6 minus 5x. Notice though it does say show all required work and all mathematical statements must be correct. And so you want to find f of 3 plus g of negative 2. So we got to find f of 3 first. So to find f of 3, remember f of 3, to find f of 3, I go to my function f, which is this one, not this one, that's g. This is f. And wherever you see my variable x, I substitute 3. So you're going to have to go to the side and do some work here. So do it in steps. Find this one first, then find this one, and then add them up, and you're done. Right? Do them in steps. So f of 3 then would be 2 times 3 squared. So wherever you see the variable x, I substitute 3 minus 3 times 3 plus 1. Order of operations says I have to do exponents first. So don't multiply. Don't say 2 times 3 is 6 and then square that. That's incorrect. You have to square first. You have to do order of operations, exponents. 3 squared is 9. 9 times 2 is 18. Minus 9 plus 1. 18 minus 9 is 9, and 9 plus 1 is 10. So this is 10. So f of 3 is equal to 10. Then I'm going to add that to g of negative 2. So then I've got to find g of negative 2. So g of negative 2, that's this function here. So make sure you're using the correct function, this linear function. Wherever you see the variable x, and I see it here, I'm going to substitute negative 2. So I get 6 minus 5 times negative 2. A negative 5 times negative 2 is a positive 10, so this becomes 6 plus 10, which is 16. So I have 10 plus 16, which is going to equal 26. So there's your answer, 26. All right, now so we talked about the algebra functions. So this notation right here, f plus g evaluated at x. Remember, that does not mean multiplication. Okay, that's not multiplication. That means f plus g evaluated at x. So by definition, this means f of 3 plus g of 3. That's what that means. And so then you do the same thing. You find f of 3, you find g of 3, and then you add them up. Well, see this f of 3, I already did that one, right? So that's already done. So that's 10. So I know that right away that's 10 because I already did that one. Now let's find g of 3. So g of 3 says I go to my function g, and wherever I see the variable x, I substitute 3. So that's going to become 6 minus 5 times 3. So 6 minus 5 times 3. So that's 6 minus 15, and 6 minus 15 is a negative 9. So that becomes 10 plus a negative 9, and 10 plus a negative 9 is a positive 1. So 1 goes there. See? G minus f at negative 1 means this. Means g of negative 1 minus f of negative 1. That's what that means. So then I'm going to find g of negative 1, find f of negative 1, and then subtract those. All right, so let's do the work. So now you can't, let me go ahead and indicate what g of x is. So g of x is 6 minus 5x. So to find g of negative 1, wherever we see the variable x, I'm going to substitute negative 1. So that becomes 6 minus 5 times negative 1. So it becomes 6, and negative 5 times negative 1 is plus 5. And then 6 plus 5 is 11. So that's 11 right here. Now we're going to find f of negative 1. So f of negative 1, I have to use my function f, which is 2x squared minus 3x plus 1. So this time, if I want to find f of negative 1, wherever we see the variable x, I'm going to substitute negative 1. So this becomes 2 times negative 1 squared minus 3 times negative 1 plus 1. Notice I put those in parentheses since x is negative here. So order of operations, negative 1 times itself is a positive 1, right? 1 times 2 is 2. Negative 3 times negative 1 is a positive 3, and then plus 1. So I get 5 plus 1, which is 6. So 11 minus 6 is going to be 5, right? So that's 5. Okay? All right. Letter D. Now remember, this closed circle right here means multiplication. That's the operation, multiplication. So f times g at negative 4 means f of negative 4 times g of negative 4. And so I'll find each of those, so do them in steps. Once you find both, then you're going to multiply them. So f of negative 4, so here's my function. So wherever you see the variable x, I'm going to substitute negative 4. So f of negative 4 is going to be 2 times negative 4 squared minus 3 times negative 4 plus 1. So wherever you saw that variable x, you substitute negative 4. Negative 4 squared 16. 16 times 2 is 32. A negative 3 times a negative 4 is a positive 12, and then plus 1. 32 plus 12 is 44, right? 44 plus 1 is 45. So f of negative 4 is 45. Now you got to find g of negative 4. So g of negative 4, this time you go to your function g, which is this one, and where we see a variable x, you substitute negative 4. So this becomes 6 minus 5 times negative 4. So it'll be 6, and negative 5 times negative 4 is a positive 20, right? And so you get 26. Now using your calculator, you're going to say 45, let's see, 45 times 26 will be 1,170. And so that's the answer there, 1,170. All right. Now we're looking at the quotient, g divided by f. So the quotient here, quotient meaning division, so that means g of 2 divided by f of 2. So g is in the numerator, f is in the denominator. So now we're going to find g of 2. So to find g of 2, I'm going to use my function g. And where we see the variable x, I'm going to substitute 2. So this becomes 6 minus 5 times 2. So that's 6 minus 10, which is a negative 4. Okay, so the numerator is negative 4. The denominator, f of 2, so this time we go to my function f, and where we see the variable x, I'm going to substitute 2. So f of 2 would be 2 times 2 squared minus 3 times 2 plus 1. 2 squared is 4. 4 times 2 is 8. So that's 8 minus 6 plus 1. Negative 3 times 2 is negative 6. 8 minus 6 is 2. 2 plus 1 is 3. So I get negative 4/3. Reduce if you can and leave it as a fraction. Don't write this as an improper fraction. Just leave it as a fraction. Reduce though. So I cannot reduce this. Don't put it as an improper. Don't put it as a mixed number. Leave it as an improper fraction. So you can say negative 4/3. And so that's it. All right. So that is the key to this worksheet on the algebra of functions.